Today we're going to talk about particle movement again, and this time the functions that I'm going to give you for the particle movement aren't going to be simple polynomials. For example, let's say a particle moves along the x-axis with position at time t of x of t is equal to e to the negative t times the sine of t. And the domain for the time is positive or 0, and it's less than 2 pi, which is about 6. So what we're going to do here is we're going to find the time where the particle is farthest to the left. And we're going to justify our answer. And this is a no calculator question. This actually came off an old AP exam. So if we're given the x of t, then what we have to do first is find the velocity function. So x prime of t, which is equal to our velocity function, is equal to, now what we have is the product rule here, first times the derivative of the second plus second times the derivative of the first. So first is e to the negative t, the derivative of sine is cosine. And then we have to add to that the second sine of t times the derivative of the first. Well, if you remember, the derivative of e to the x is just e to the x. So we have e to the negative t, which is the derivative of e to the negative t. But the chain rule says we have to multiply it by the derivative of the exponent. The derivative of negative t is -1. So there's our velocity function. And now we're going to simplify that. What we want to do is we want to set the velocity equal to 0, because that's when we figure out the velocity, we can figure out that it's traveling to the right and then to the left, and it turns around where the velocity is equal to 0. And changes signs. It turns around, or it changes direction. So what we're going to have to do is we're going to have to set this equal to 0. Well, the way to do that is factor it completely and set each factor equal to 0. So what we have here is a common factor of e to the negative t, so we'll pull that out, e to the negative t, and what we're left with is the cosine of t. Oops. The cosine of t, and this is a negative, so minus the sine of t. And if you remember the negative exponents means that this term is going to move to the denominator and the exponent becomes positive. So just to save a little bit of room, I'm going to just cross this out and call this e to the positive t in the denominator. So there's our velocity function. And what we have to do is set this equal to 0, and we can figure out where it changes direction, and we can set up a sign table for this velocity function. So the critical values are when the cosine of t minus the sine of t is equal to 0. And if you remember the exponential function, e to the t is never going to be equal to 0. There's no value of t that you can plug in that will make this term equal to 0. So the denominator doesn't have a critical value. The numerator does. What we're going to do is if it's equal to 0, we can just add sine of t to both sides, or in other words, set cosine of t equal to the sine of t. Well, I hope you remember from Algebra 2 what value of theta the cosine and the sine are equal to each other, but if you forgot that, then you can just draw a little cosine curve and a sine curve going out to 2 pi and dividing this up into 4 equal spaces. And so we have pi and pi over 2 and 3 pi over 2. And we're going to sketch a little cosine curve and a sine curve and find out where they're equal to each other because we don't have a calculator that we can use. So a cosine curve goes 1, 0, -1, 0, 1. So here's our cosine curve. And our sine curve starts at the origin. So here's a cosine up here. The sine curve starts at the origin, goes 0, 1, 0, -1, 0. So here's our sine curve. Cosine of t is on the top, starts up here, and then the sine of t comes around here. Well, where are they equal to each other? Well, they're equal to each other where they intersect. And when they intersect each other, it's exactly halfway between 0 and pi over 2, which is pi over 4, or 45 degrees. And they also intersect each other right here, halfway between pi and 3 pi over 2. And that's actually 225 degrees, which is 5 pi over 4. So t has two values, pi over 4, which is 45 degrees. If you remember, cosine of 45 and the sine of 45 are both the square root of 2 over 2. And 5 pi over 4, that would have a third, this is a third quadrant angle, so both sine and cosine are negative square root of 2 over 2. So we have some critical values. The next thing we want to do is we want to set up a sine table to find out if the velocity changes signs at these particular values. So we have t equals 0 starting us off, and then we have t is equal to pi over 4, our first critical value. Then we have t is equal to 5 pi over 4, our next critical value. And then last, our domain ends at 2 pi. So we'll put 2 pi on our v of t sine table. So now what we're going to do is we're going to plug in, or we're going to estimate whether or not this portion of this graph is going to be positive or negative. And it's kind of hard to tell because we don't know the exact values, or actually we could figure out if we want, this is 45 degrees, if we wanted to plug in 30 degrees into this v of t, cosine of 30 minus sine of 30 all over e, this would always be a positive number. We could do it that way, but let me show you an easier way. When the cosine graph is above the sine graph, which happens between 0 and pi over 4, if you subtract cosine minus sine, you're going to get a positive value, cosine minus sine. So this velocity function has a positive numerator. Denominator is always going to be positive, so we have a positive over a positive, which is going to lead to a positive velocity function. Now we're going to look at all the values between pi over 4 and 5 pi over 4. So here's pi over 4 and here's 5 pi over 4. So in this area, the sine is above the cosine. So if you subtract a larger from a smaller value, you're going to get a negative on the numerator. And this is always positive, so we have a negative over a positive, which gives us a negative. And then we move to here where the cosine is greater than the sine, and so we have, again, a positive value. So what happens to the particle? It moves to the right, then it moves to the left, and then it moves to the right. So what we're going to do is we're going to find some positions at those critical values. The critical values are x of 0, the endpoint, x of pi over 4, x of 5 pi over 4, and x of 2 pi. Well, what we have, x of 0, we go all the way back to the original function, the position function. That tells where on the x-axis this particle is going to be. And if you plug in 0, the sign of 0 is 0, so 0 times anything is going to be 0. So that's where the particle starts. That's the initial position, where t is equal to 0. And then you go to pi over 4. So if you plug in pi over 4 into this position function, you have 1 over e to the pi over 4 times the sine of pi over 4. And the sine of pi over 4 is the square root of 2 over 2. So this position would be the square root of 2 over e to the pi over 4 times 2. And this is the position at t is equal to pi over 4. 5 pi over 4 is exactly the same thing. The only difference is the sine of 5 pi over 4 is going to be negative. So this value right here is just going to be the same as above, but negative. So negative square root of 2 all over 2 times e to the 5 pi over 4. So because this is negative, this looks like it's the leftmost position, because when you get to 2 pi, the sine of 2 pi is going to be 0, so it actually ends up at 0. So because this is a negative value, it is the furthest to the left. So the question was, find the time t when the particle is furthest to the left, and the time is 5 pi over 4, furthest to the left. Because we have an initial position of 0, it moves to the right because this is a positive value, then it moves to the left and becomes a negative value, and it turns around and it ends right back up at the origin. So this is the justification. And another thing we can say about this function is, because we know that this is a turnaround spot at t equals pi over 4, we know that this point right here being positive is the furthest to the right if we were asked that question, but we weren't. But we'll just say so anyways, what the heck. So t is equal to pi over 4 means the furthest to the right. And so that distance from the origin is this crazy number here. Who knows what that is unless we take out a calculator and calculate the square root of 2 over e to the pi over 4 times 2. But let's just really quickly put our x-axis here. This is not a sine table, this is the x-axis. And so this particle started at x equals 0, and x equals 0 at time equals 0. And then we said it started moving to the right, and it got over to the right. The position was the square root of 2 over e to the pi over 4 times 2. So it moved to the right, and that's at t equals pi over 4. And then it moved to the left until we got to negative square root of 2 over 2 times e to the 5 pi over 4. And then it turned around again, and it moved back to the right, and it ended up at the origin, right where it started. So this goes to the right, and then to the left, and then to the right, and it stops where it started. If we wanted to know the total distance that it traveled, all we'd have to do is add this distance to this distance, because it went from here, and then it went all the way back to here. Oh, and then it went, actually we have 3 distances to add. So the total distance is this distance, which is a square root of 2 over e to the pi over 4 times 2, plus another one of those, plus this distance, plus this distance back again. So there are a lot of distances if we'd like to calculate those. Actually, I'm not going to put it in the calculator, but let's just write that out because I'm going to do another much simpler example to talk about the total distance traveled. Okay, so the distance between 0, this is t equals 0 to pi over 4. It traveled a distance of the square root of 2 over e to the pi over 4 times 2. I guess I'll put the 2 out here. And then it traveled that much back again. So it actually, you can add that to itself again, or you can just multiply it by 2. So that's there and back again. And then you add to that, it traveled from this point, the origin, back this way, which is the distance is the absolute value of that. So I'm just not going to put that negative on here. So we've got the square root of 2 over 2e to the 5 pi over 4. That's this distance here. And then it traveled back that much again, so we have actually 2 of them. So the only thing we can really do here is we can cancel out those 2's because they're common factors. But we don't even have to do that. That is the total distance traveled by that particle. And if we wanted to figure out that as a decimal, we can certainly throw it in our calculator and figure out decimally how that turned out. But we're not going to do that. Let's do a simpler example on total distance traveled.
Actually, no, I think let's do it more.
So for the total distance traveled example that I'd like to give you, let's say we have x of t equal 1/3 t cubed minus t squared minus 3t plus 4. And the particle is traveling between t is equal to 0 all the way up, and it stops at t equals 6. So we've got this definite interval where the particle is traveling. What is the total distance traveled by the particle? Well, what we want to do is we want to figure out, like we had before, which particle or which direction the particle moves, where it turns around. So let's calculate v of t. V of t is equal to t squared minus 2t minus 3. And so if we factor that out, we get t minus 3 times t plus 1. So v of t is equal to 0 when t equals 3, but not t equals -1 because that's out of the domain. So t equals 3 is a point where it has a turnaround, probably. Let's get a sign table going of v of t to find out which direction it travels in. So we've got t equals 0, we've got t equals 3, we've got t equals 6, and this is our v of t sign table. All right, so if we plugged in a 1 into v of t, we get 1 minus 2, which is negative, minus 3, which is another negative. So what we have is this particle is traveling to the left. And then if we plug a number between 3 and 6 in, let's plug in 4. We have 16 minus 8, which is 8, minus 3, which is positive. So it's traveling in the positive direction, which is to the right. So we've got left and right. Okay, now let's find out what x of 0 is, what x of 3 is, and x of 6 is, to figure out what the position is. And then we can put that on the x-axis, and we can figure out how far this particle has moved. So x of 0, that's the initial position. X of 0 is equal to 4, just 0, except for that 4. X of 3 is equal to 1/3 times 27, which is 9, minus 9, minus 9, plus 4. And if you add all those up, I believe you get -5. And then we have to figure out what x of 6 is, because that's where it stops. This is where it starts, this is where it turns around, and this is where it stops. So x of 6 is 1/3 of 6 cubed, 216, divided by 3, minus 6 squared, which is 36, minus 18, plus 4. X of 6 turns out to be 22. So what's the total distance that that particle has traveled? Well, it starts out at 4, at time equals 0. Then it moves to the left until it gets to a -5 position. And then it ends at x equals 22, so it stops here. So what's the total distance traveled? The total distance is, what's the distance between +4 and 5? This distance is 9. And what's the distance between -5 and 22? 22 plus 5 is 27. So the total distance, which all you do is subtract 4 minus -5 is 9. 22 minus -5 is 27. And you add those up, and 36 units equals the total distance traveled. And I think that's about it for tonight. We'll get some practice on this tomorrow.